13 and 14 are kind of similar problems, but also very different. 13 is looking for the value of k, 14 is looking for the value of c. Let's look at 13 first. So we're dealing with a power function. It says that suppose f of 6.6 is 6.2 times as large as f of 1.76. What is the value of k? So I do want to take those input values and write them as a fraction. And this is going to tell you really how much larger the inputs are. I don't want to actually figure out this number because I don't want to round it. But I do know if I raise this to the k, that this is going to be equal to how much the outputs increase by, or by 6.2. So this will be my setup. Now, my next step, I actually want to take the logarithm of both sides. So we're kind of bringing back logarithms. So take the log of both sides. So this is going to be the log of 6.6 over 1.76 raised to the k is equal to the log of 6.2. Now, one of the advantages to taking the log is that you're allowed to move the power out in front. And you can only do that if there's a logarithm there. So this will be k times log of 6.6 over 1.76 is equal to log of 6.2. And then we want to divide both sides by log of 6.6 over 1.76. So this will be log of 6.2 divided by log of 6.6 over 1.76. And this is something you can type in on your calculator. So if you do this, you should get k is equal to 1.38. So that would be the power k. On 14, again, this is a different problem. It says let f equal c times x to the 4.2. Suppose that f of 4 is equal to 8. What is the value of c? So they give us basically all the values. The f value is 8 is equal to c, I don't know. That's what I'm trying to find. The x value is 4, and the k they already give you as 4.2. So c is equal to 8 divided by 4 raised to the 4.2. So c would be equal to 0.02.